Before we journey into the deep, dark heart of the cosmos, let us first quiet our minds. Imagine a place where silence truly reigns, a stillness so profound it hums with unseen energy. Here, our exploration begins, not with a bang, but with a gentle whisper inviting you to wonder about the spaces where light itself takes its leave dot as your breath deepens and your body settles into quiet comfort. Allow your mind to drift. Imagine the stillness around you, the gentle hush of the world as it prepares for slumber. This quietness, this soft retreat from the day's sounds, is a wonderful beginning for our journey. We are going to explore the universe's most profound silences, places where even light, the swiftest messenger, can find no voice. Close your eyes if you wish and feel the vastness within. This inner quiet is a gateway to the cosmic quiet. For tonight, we travel to places not seen, but felt, not heard, but understood through the whispers of science. We begin with nothingness, a word that seems simple, but in the cosmos, it holds a secret, a profound depth that will gently unfold before your mind's eye. When you look up at the night sky, away from the city lights, you see patches of darkness between the stars. It seems empty, a void. For a long time, we thought of space as exactly that, simply empty, a boundless canvas upon which the stars were painted. But even in the deepest, darkest stretches of space, there is never truly nothing. There are echoes of the Big Bang faint, distant ripples of energy. There are stray atoms, a whisper of gas, a scattering of cosmic dust. And there are the invisible fields that permeate everything, holding the universe together with unseen threads. So what then is this nothingness we seek? Our journey leads us to a specific kind of cosmic nothingness, a profound absence that is, paradoxically, filled with unimaginable presence. It is a place where gravity has become the absolute ruler, so mighty that it warps and bends everything around it, including the very fabric of space and time. This is not the emptiness of a vacuum, but the emptiness born of such intense concentration, such incredible density that nothing, not even the brightest spark, can escape its grasp. Picture, if you will, a perfect still pool of water. A tiny ripple travels across its surface, moving outward, reflecting the light. Now imagine a place in this cosmic pool where the water is not still, but rather flowing inward, ever faster towards a central point. Any ripple, any ray of light that reaches a certain distance from this point is caught. It is pulled in, unable to move against the powerful, unseen current. This is the nature of the nothingness we speak of tonight. It is an active, consuming darkness, not merely a passive absence of light. These places are called black holes, a name that perfectly describes them, yet also hides their true nature. They are not holes in the traditional sense, not tunnels or portals to another dimension, though they are often imagined that way. Instead, they are regions of spacetime where gravity is so strong that nothing, no particles or even electromagnetic radiation like light can escape from inside it. Think of it as a cosmic trap set by gravity itself. The story of black holes begins not with observations, but with equations. Long before we had any hint of their existence, brilliant minds like Albert Einstein, with his theory of general relativity, laid the mathematical groundwork. His equations described how mass and energy warp the fabric of space-time, much like a bowling ball placed on a stretched rubber sheet. The heavier the ball, the deeper the dip, and the more profound the curvature. When a star, immensely heavy and massive, collapses under its own gravity, its density becomes so extreme that it creates an infinitely deep well in this cosmic sheet. This infinitely deep well is where light goes to disappear. Light, which we perceive as moving in straight lines, actually follows the curves of space-time. So as light approaches a black hole, it finds the path ahead of it bending more and more acutely towards the center. At a certain point, known as the event horizon, a boundary we will explore more deeply in another gentle drift, the curvature is so extreme that any light ray, no matter its direction, is bent back towards the black hole's center. It's like trying to run upstream against a waterfall that suddenly turns vertical. The current is simply too strong. This is why they appear black. Not because they are empty, but because they are perfectly efficient light eaters. Every photon, every tiny packet of light that strays too close is absorbed, never to return. And because we see things only when light from them reaches our eyes, a black hole is, by its very nature, invisible to us directly. We cannot see the hole itself, only its profound effect on everything around it. It is the ultimate cosmic shadow cast by an object so dense that it leaves no trace of its own light, yet this invisibility makes them all the more compelling. They challenge our very perception of existence. How can something so massive, so powerful, be utterly unseeable? It forces us to rely on our understanding of physics, on the indirect clues they leave behind. We observe their presence by the way they pull on nearby stars, causing them to orbit around nothing visible, or by the fiery dance of gas and dust, spiraling into their silent depths, heating up to brilliant temperatures just before their final plunge. Rest now. With this image in your mind, a place of ultimate quiet, a cosmic vacuum cleaner, not of air, but of light itself. A region where the universe has folded in upon itself, creating a silent, powerful vortex. It is a profound mystery, a testament to the extremes of nature, yet it exists as a fundamental part of our universe, shaping galaxies and quietly awaiting our understanding. Tomorrow night, we will gently explore the very force that sculpts these magnificent voids, the unseen hand that gathers stars and light into such profound stillness. We will delve into gravity's deep and quiet embrace, the powerful pull that begins this incredible transformation. Gravity's gentle embrace. Feel the subtle pull of everything around you. A soft, invisible hand guiding stars and dust. Tonight, we drift deeper into gravity's vast ocean, where its currents grow so strong they weave the very fabric of space into new forms. It's a dance of cosmic proportions, a silent waltz between immense power and quiet surrender. As you lie here, safe and still, become aware of the quiet force that holds you gently to your bed, that keeps the cup on your knitstand from floating away, that pulls the rain softly to the earth. This is gravity, our constant companion, an invisible hand that cradles you always. It is the most familiar of cosmic forces, yet also one of the most profound, a silent sculptor of worlds and the architect of grand celestial ballets. Imagine it not as a harsh, unyielding tug, but as a vast, unseen ocean in which everything exists. You are floating on its surface, held by its gentle currents. Even the air you breathe, the light filtering through your window, every speck of dust dancing in a sunbeam, all are under gravity's soft, persistent influence. It is a force that knows no boundaries, reaching out across the immense void between planets and stars, knitting the universe together with unseen threads of connection. Think of our own solar system, a delicate mobile spinning silently in the cosmic dark. The mighty sun at its heart exerts a powerful yet gentle gravitational embrace. It is this embrace that keeps Earth, with all its oceans and mountains and quiet sleeping inhabitants, from hurtling wildly into the darkness. It keeps Mars and Jupiter and Saturn, each a unique jewel, orbiting in their graceful, predictable paths. They are all caught in the sun's silent waltz, never touching, yet forever bound. This invisible choreography is gravity's artistry, performed on a scale beyond our easy comprehension, yet felt in every steady beat of a planet's journey. Gravity is unique among the universe's fundamental forces. It is paradoxically the weakest of them all at tiny, everyday scales. You can easily lift a pencil against the gravity of the entire Earth. A small magnet can pick up a paperclip, effortlessly overcoming the pull of our immense planet. Yet, when mass gathers on a grand scale, gravity becomes the undisputed monarch. It is the whisper that becomes a roar when countless whispers combine. It is the gentle current that becomes an unstoppable river when all its tributaries merge. Asterisk, for gravity is born from mass. Every atom in your body, every particle in the air, every molecule in the bed beneath you contributes its tiny share of gravitational pull. But it is the accumulation, the immense gathering of matter, that truly awakens its power. A tiny pebble has a tiny pull. A mountain has a stronger pull. A planet with its vast interior has a mighty pull. And a star, a colossal ball of gas, burning for billions of years, exerts a gravitational force that shapes its very existence and the destinies of worlds around it. Imagine a star, much larger than our sun, living out its long and luminous life. Throughout its existence, there's a delicate balance within it. The outward pressure from the fiery nuclear reactions happening in its core pushes against the inward squeeze of its own immense gravity. It's a cosmic tug of war, keeping the star stable, round, and radiant. For billions of years, this balance holds. But nothing lasts forever, not even stars. When a very massive star begins to run out of its nuclear fuel, the outward push from its core weakens. And when that push fades, the mighty, unrelenting hand of gravity, which has been there since its birth, takes over completely. Without the internal resistance, the star can no longer hold itself up. It begins to collapse rapidly, violently, inward upon itself. Think of squeezing a vast, fluffy cloud of cotton candy down into a tiny, dense marble. All that original material, all that incredible mass is forced into an unbelievably small volume. As the star's matter collapses, its density skyrockets. And as density increases, the gravitational pull at its surface becomes unfathomably strong. It's like concentrating all the pull of a vast ocean into a single, infinitesimally small point. The currents of gravity, once gentle, become a raging, inescapable torrent. This extreme compression, this ultimate act of cosmic density, is what gives birth to the most profound gravitational wells in the universe, black holes. The entire mass of a giant star, or even many stars, is condensed into a space perhaps no bigger than a city, or even smaller than an atom. And from this infinitesimally tiny, infinitely dense point, gravity's embrace becomes absolute. It is now longer just pulling on distant planets. It is pulling on the very fabric of space itself, drawing it inward, stretching it, and bending it into an entirely new configuration. It's as if the vast, smooth surface of our cosmic ocean is not merely rippled by gravity, but deeply, profoundly warped. Tomorrow night, as you drift further into sleep's gentle embrace, we will unfold this very idea, exploring how gravity doesn't just pull, but how it profoundly shapes the very stage upon which the universe performs its grand silent dance. The fabric unfurls. Close your eyes and envision space not as empty void, but as a vast, delicate tapestry. Now imagine a heavy bead placed upon it, causing the threads to curve and dip. This gentle bending, this cosmic deformation, shapes the paths of light and time, leading us to understand the heart of these mysterious cosmic forms. Rest gently, allowing your mind to unfurl like a quiet sail catching a soft breeze. Last night, we felt gravity's tender pull, the unseen hand guiding all things in the universe. Tonight, we deepen our understanding of this force, not as a simple tug, but as a profound shaper of reality itself. Imagine, if you will, the universe not as an empty stage upon which stars merely exist, but as a vast, seamless fabric. This is not just any fabric. It is the fabric of space-time. Think of it as an infinitely large, incredibly smooth sheet, perhaps made of the finest, most pliable silk, stretching endlessly in all directions. It is everywhere, around you, above you, through every distant galaxy. This isn't just an empty void. It is the very medium of existence, the stage upon which all cosmic dramas play out. Now, picture placing a small light marble onto this vast, flat sheet. It causes a tiny, almost imperceptible dimple, a slight depression. This dimple is a representation of the gravitational field of that marble, its subtle influence on the fabric. If you roll another, even tinier, marble nearby, it will not be pulled by the first marble in the way you might imagine. Instead, it will simply follow the gentle curve that the first marble created in the sheet. Its path is altered not by an invisible rope, but by the very shape of the space it travels through. Now, replace that tiny marble with something truly immense, something unimaginably heavy, like a star. As we learned last night, stars are colossal concentrations of mass. When such a weighty object is placed upon our cosmic sheet, it doesn't just create a dimple. It creates a profound, deep depression. The fabric of space-time bends and stretches around it, forming a grand, sweeping curve, like a bowling ball resting on a trampoline. The heavier the star, the deeper and wider the dip it creates. This profound bending of the fabric is how gravity truly works according to the insights of Albert Einstein's general relativity. It is not a force pulling from a distance, but rather a consequence of mass and energy telling space-time how to curve, and space-time in turn telling matter and light how to move. So when Earth orbits the sun, it's not because some invisible rope is pulling it. It's because the sun's immense mass has created a vast, deep well in the space-time fabric, and Earth is simply following the contours of that well, like a ball rolling around the inside of a huge bowl. It is a graceful, inherent motion guided by the shape of its surroundings. Consider now the journey of light. We often think of light as traveling in perfectly straight lines, shooting like an arrow from one point to another. And it does in flat, uncurved space. But on our cosmic sheet, if the sheet itself is curved, then the straightest path available to light will also appear curved to an outside observer. Imagine an ant walking in a straight line across the surface of a globe. From its perspective, it's walking straight, but to someone looking down from above, its path appears to curve along the surface of the sphere. Light behaves similarly in the curved space-time around massive objects. It follows the existing curves, bending around stars and galaxies, painting distorted cosmic portraits across the sky. But the fabric of the universe isn't just space, it is space-time. This means that time itself is intertwined with space, woven into the very same cosmic tapestry. And just as mass can bend space, it can also bend time. This is a subtle and wondrous concept, so let it settle gently in your mind, near a very massive object. In the deep well of space-time created by a star or a galaxy, time actually slows down. It stretches out like a slow-motion dream. If you were somehow able to stand very close to a massive star, and a friend stayed far away, your clock would tick ever so slightly slower than theirs. Your moments would be a little longer, your breath a little deeper, stretched by the immense gravitational field. It's a tiny, almost imperceptible effect in our everyday lives, but it is real. And it is a profound testament to the interconnectedness of space and time. Now, let us return to the fate of the colossal stars we spoke of last night, those magnificent beings that eventually collapse under their own immense gravity. As such a star shrinks, concentrating all its incredible mass into an ever smaller volume, the depression it creates in the space-time fabric becomes unimaginably deep. The well becomes a chasm, The gentle curve transforms into a dizzying vertical plunge. Imagine squeezing our stretched silk sheet down, gathering all its material into a tiny, dense knot. The threads around this knot would be pulled taut, stretched, and folded in on themselves in an extreme way. This is what happens to space-time around a collapsing star. The fabric of the universe doesn't just dip. It becomes so profoundly warped that it folds inward, closing in on itself. Asterisk, at the very center of this extreme fold is the heart of a black hole, a place where the fabric of space-time becomes infinitely curved, and all the mass of the original star is thought to be compressed into a single, infinitely dense point. But for us, for our quiet journey, it is enough to understand that this is where the ordinary rules of space and time begin to unravel. It is where the very stage of the universe becomes so bent, so distorted, that light and even time itself can no longer find a way back out. This incredible warping of the fabric, this profound dip in space-time, marks the point of no return for anything that falls into its grasp. It is a boundary where the deepest secrets of gravity are truly revealed, and the paths of light and time become forever one-way streets. Tomorrow, as you drift further into sleep's gentle embrace, we will approach this shimmering, silent boundary, the ultimate veil beyond which light itself takes its leave. Echoes from the edge, what remains of a star that has lived its magnificent life, now drawn into the profound embrace of the unseen. Listen closely to the faint, lingering echoes, the whispers of energy and matter that swirl at the very edge of the cosmic abyss. These are the last lullabies of light before silence claims its eternal reign. As you rest in the soft embrace of the night, recall our journey to the event horizon, that shimmering, invisible veil beyond which light itself takes its leave. We understood how nothing escapes its grasp, creating a profound, impenetrable darkness. Yet paradoxically, these silent cosmic giants, these black holes, are not entirely silent. They leave behind echoes, profound whispers of their presence that resonate across the vastness of space. Imagine a grand cosmic ballet, a slow, mesmerizing dance between a black hole and a nearby star. Even though the black hole itself remains unseen, its immense gravitational pull is a powerful partner in this dance. If a star, through its own celestial wanderings, drifts too close, it begins to feel that overwhelming, unseen hand. Its outer layers, the very essence of its being, can be gently, then more forcefully, stripped away. This stripped away stellar material, gas, dust, and plasma doesn't immediately vanish into the black hole. Instead, it forms a magnificent swirling disk around the black hole, much like water swirling around a drain, but on an unimaginable cosmic scale. This is called an accretion disk. It is a vast, flat spiral of matter drawn inexorably inward, yet still just outside the event horizon. As the particles within this disk spiral closer and closer to the black hole's ultimate embrace, they rub against each other with incredible friction. Imagine grains of sand, each moving at immense speeds, colliding and grinding against their neighbors. Friction heats them to astonishing temperatures, millions of degrees hot, so hot that they glow not just with visible light, but with invisible forms of light like X-rays and gamma rays. These brilliant emissions are the black hole's loud, radiant voice in the universe, its most magnificent echo. Think of it as a cosmic lighthouse that doesn't emit light from itself, but from the furious, fiery dance of matter just before it enters the ultimate darkness. We cannot see the black hole, but we can see the desperate, brilliant last moments of the gas and dust caught in its gravitational current. These X-ray and gamma-ray signals travel across billions of light years, reaching our telescopes as silent, powerful messages confirming the presence of an unseen Leviathan. They are the last, fiery lullabies of matter, singing farewell before its final, silent plunge into the void. Beyond these blazing accretion disks, there are other, more subtle echoes. Sometimes twin jets of incredibly energetic particles erupt from the vicinity of a black hole, shooting out into space at nearly the speed of light, far above and below the accretion disk. These powerful outflows, perhaps guided by intense magnetic fields near the black hole, can stretch for thousands of light years, carving out vast cavities in the gas and dust of a galaxy. They are like cosmic geysers, silent yet immensely powerful, driven by the unseen engine at the center dot, and then there are the gravitational echoes. These are perhaps the most profound whispers of all. When massive black holes collide, or when they consume huge stars, they send ripples through the very fabric of space-time. These ripples, called gravitational waves, spread out like the gentle circles on a pond after a stone has been dropped. They are incredibly faint, imperceptible to our senses, yet we have built magnificent detectors here on Earth, instruments sensitive enough to feel these minuscule stretches and squeezes of space-time as the waves pass through our planet. Imagine a cosmic bell ringing out in the deep silence, not with sound, but with gravitational vibrations. These are the sounds of black holes merging, their final cataclysmic dance echoing across the cosmos. These echoes are not electromagnetic light, but pure distortions of space-time itself, carrying direct information about the most violent events in the universe. They tell us of a new kind of cosmic symphony, one played on the very fabric of reality. We also find black holes through their effect on nearby stars. Picture a solitary star orbiting around an empty point in space. It's dancing with an invisible partner. We can measure the star's speed, its orbital path, and deduce that there must be an enormous, unseen mass at the center of its orbit. This unseen mass, which emits no light, yet exerts such powerful gravity, is a telltale sign of a black hole. These are the quiet, rhythmic echoes of stellar orbits, tracing out the invisible presence of the void dot. So while a black hole itself is shrouded in ultimate secrecy, it leaves behind a rich tapestry of evidence. Its presence is revealed in the brilliant X-rays from superheated gas, in the powerful jets of particles blasting into space, in the subtle ripples of gravitational waves, and in the stately orbits of stars around an invisible center. These are the cosmic clues, the silent declarations of its profound existence. Rest now with the knowledge that even the most mysterious objects in the universe leave their mark, their subtle whispers reaching us from the edge of the known. These echoes tell us of lives lived and ended, of transformations beyond our imagining, hinting at the powerful forces that shape the destiny of stars themselves. And it is to this grand transformation, this spectacular demise, that we shall turn our thoughts tomorrow night, as we consider how a star's glorious life can end in such a profound, silent yet powerful rebirth. There comes a point of no return, a threshold where even the swift dance of light falters and fades. We approach this shimmering horizon not with fear, but with quiet awe, contemplating the boundary where familiar physics gently steps aside, and the deepest secrets of the universe begin to unfold. As you rest in the deepening quiet, let your mind once more drift towards the vast, unfurling fabric of space-time we explored last night. We understood how massive objects create deep wells in this cosmic tapestry, bending the very paths of light and time. Tonight, our gentle journey brings you to a crucial, almost magical boundary, a shimmering, unseen line around a black hole where the rules of escape simply cease to exist. This is a threshold known as the event horizon. Imagine yourself floating gently towards the edge of a great cosmic waterfall. From a distance, the water flows peacefully, but as you draw nearer, the current quickens. You can still easily paddle away back towards the calm. This is much like space far from a black hole. Light and matter can come and go as they please. But there is a point, an invisible line, where the water's flow becomes as swift as your fastest paddle stroke. Cross that line, and no matter how hard you try, no matter how much energy you exert, the current will pull you over the edge. You are beyond the point of return. The event horizon is precisely this kind of cosmic threshold for a black hole. It is not a physical surface, not a wall or solid barrier you can touch. Instead, it is a boundary in spacetime itself, defined by the extreme curvature of the fabric around the incredibly dense mass at the black hole's heart. Think of it as the ultimate one-way gate. Anything that crosses this invisible line, be it a stray photon of light, a wandering atom of gas, or even a star that has ventured too close, is inexorably pulled inward. Once inside, escape is simply impossible for anything. Why is escape impossible? Because within the event horizon, the very fabric of space-time is curving inward so dramatically that all paths, no matter which direction you try to travel, lead only towards the black hole's center. It's as if the forward direction for everything inside has become irrevocably inward. To try and escape would be like trying to run north on a planet where all roads, by the very nature of its geometry, suddenly lead only south. There is no outward direction available, not for light, not for matter, not for anything. Even light, the fastest thing in the universe, experiences this fate. Just outside the event horizon, a beam of light could still, theoretically, escape if it angled itself perfectly away from the black hole. But once it passes that critical boundary, the light rays are caught in spacetime's overwhelming inward current. They are dragged back, their forward momentum overwhelmed by the immense gravitational pull. And since light is the swiftest of all, if light cannot escape, then nothing else can either. This is the reason black holes are truly black. No information, no signal, no photon can ever reach us from beyond that veil. Asterisk. This concept of a point of no return has profound implications. It means that the black hole's interior is completely cut off from the rest of the universe. It is a region of ultimate isolation, a silent cosmic vault that holds its secrets tightly. What happens inside the event horizon remains forever veiled from our direct observation. We can only infer, predict, and wonder based on our understanding of physics. Consider the journey of something falling towards this boundary. As an object, perhaps a cloud of gas, spirals closer and closer to the event horizon, it experiences extreme conditions. The gas heats up dramatically due to friction and compression, glowing intensely in X-rays and gamma rays before it finally crosses the point of no return. These brilliant emissions are often our strongest evidence for the existence of black holes, not the black hole itself, but the fiery dance of matter just before its final silent plunge. It's like seeing the bright spray of a waterfall without seeing the waterfall itself. And what about time? That precious dimension we spoke of last night? As we learned, time slows down near massive objects. But as an object approaches the event horizon of a black hole, this time dilation becomes extreme. For an observer far away, watching something fall towards a black hole, time would appear to slow down for the falling object. It would seem to move slower and slower, its light becoming redder and dimmer, eventually appearing to freeze just at the event horizon, never quite crossing it from our distant perspective. It would fade from view, stretched into eternity, an infinitely slow descent into the unseen. But for the falling object itself, time would continue to flow normally. It would feel no slowing, no strange distortion of its own moments. It would simply pass through the event horizon without feeling anything particularly special at that exact instant. The real difference would be that, once inside, all future paths lead to the singularity, the infinitely dense point at the very center, and escape becomes a concept devoid of meaning. This boundary, this event horizon, can vary greatly in size. For a black hole formed from a collapsed star, it might be only a few miles across, perhaps the size of a small city. For the supermassive black holes at the centers of galaxies, it can stretch for millions or even billions of miles, encompassing entire solar systems within its silent embrace. Yet, regardless of its size, its nature remains the same, a point of no return where light surrenders its struggle against gravity's overwhelming embrace. This concept, while born from complex mathematics, is truly poetic in its simplicity. It speaks of boundaries, of endings that are not really endings, but transformations into a state beyond our everyday experience. It invites us to consider what it truly means for something to be invisible or gone when its profound influence continues to shape the cosmic landscape. The event horizon is a testament to the universe's capacity for extreme phenomena, a quiet challenge to our conventional understanding of space, time, and destiny. As you drift now, let your mind quietly ponder this veil of light, this cosmic boundary where the rules gently shift. What truly lies beyond, within that profound, unseen space? And what becomes of the echoes, the lingering whispers of light and energy that dance at its very edge, just before they are claimed by the ultimate silence? Stellar demise, cosmic rebirth, every ending in the universe is but a quiet prelude to a new beginning. As giant stars gently collapse into themselves, they don't truly vanish. Instead, they transform, becoming the architects of new cosmic structures, silent guardians of the future, holding the seeds of galaxies yet to be born within their enigmatic hearts. As you settle deeper into the quietude of this moment, recall the lingering echoes we spoke of last night, the fiery dance of matter at the black hole's edge, the faint ripples of gravitational waves. These whispers from the deep cosmos hint at profound transformations, at endings that are, in the grand cosmic tapestry, merely breathtaking beginnings. Tonight, we gently contemplate the magnificent demise of stars and how they're spectacular, and sows the seeds for entirely new cosmic life. Imagine a star, perhaps 20 times more massive than our own sun, living a brilliant, fiery existence. It is a cosmic furnace, tirelessly fusing lighter elements into heavier ones in its core, blazing with an intensity that lights up vast swaths of space. For millions of years, it burned brightly, a radiant sentinel in the galactic night. But even the grandest stories have an end, and for these giants, their magnificent lives are finite. As a massive star consumes its nuclear fuel, tirelessly transforming hydrogen into helium, and then helium into carbon, oxygen, and even heavier elements. It slowly approaches its final act. The outward pressure, which has for so long balanced the immense inward pull of its own gravity, begins to wane. It's like a gentle breath slowly exhaling, losing the power to hold back an inevitable inward tide. When the star's core runs out of fuel capable of fusion, or when it tries to fuse iron, an element that saps energy instead of releasing it, the delicate balance is irrevocably lost. At this precise, dramatic moment, gravity, that ancient, silent sculptor, takes over with overwhelming force. The colossal stellar core, which has supported the star for eons, collapses in mere milliseconds. It crumples inward with such incredible speed and power that it rebounds off its own impossibly dense center, sending a shockwave rippling outward through the star's remaining layers. This is no gentle sigh. This is a cosmic crescendo, the universe's most spectacular fireworks display, a supernova. Imagine a giant, radiant balloon suddenly imploding, then exploding outward with unimaginable violence. The star's outer layers, still containing the precious elements forged in its fiery heart, carbon, oxygen, nitrogen, and even heavier ones like gold, Silver and uranium are flung across the cosmos at immense speeds. These are the precious building blocks of planets, of water, of every living thing, including you and me. We are, quite literally, made of stardust, forged in the hearts of ancient dying stars, then scattered across the universe in these glorious, violent farewells. But the story doesn't end with the explosion. While the outer layers are cast out into the galactic veins, the core, the very heart of the star, continues its collapse. If the original star was massive enough, that inward squeeze becomes so intense that even the very atoms are crushed out of existence. Protons and electrons are forced together to form neutrons, creating an incredibly dense neutron star. But if the star was truly colossal, even the resistance of neutrons cannot withstand gravity's ultimate embrace. The collapse continues past the point of any resistance until all the original star's immense mass is concentrated into an infinitely small, infinitely dense point, the singularity, hidden forever behind the event horizon. And so, from the ashes of a magnificent stellar life, a black hole is born. It is a powerful, silent guardian of the future, a cosmic anchor formed from the very essence of a star's demise. Its birth is not an ending to matter, but a transformation of it, into the most extreme form of gravitational concentration known to the universe. The material that was flung outward becomes the raw ingredients for new celestial objects. The central core becomes the profound, light-absorbing void. These supernova events are not just spectacular light shows. They are essential for cosmic evolution. Without them, the universe would be a far simpler, less interesting place, filled only with hydrogen and helium. It is in the fiery crucible of dying stars and in the shock waves of their explosions that the elements necessary for life, the iron in your blood, the calcium in your bones, the oxygen you breathe, are created and then distributed across the galaxy. Each time a massive star dies, it enriches the cosmic environment, fertilizing the interstellar clouds for future generations. So, when you gaze upon the night sky, remember that the distant stars are not just burning suns. They are also cosmic alchemists, tirelessly working to create the very stuff of which everything is made. And when they reach their glorious end, they offer a final, breathtaking gift to the universe. Scattering their precious creations far and wide, rest gently with this wondrous thought, that life, even in the cosmos, is a continuous cycle of ending and beginning. From the most dramatic stellar demise comes the possibility of new stars, new planets, new forms of existence. The quiet black hole, born from such a violent end, stands as a testament to this profound transformation, silently, awaiting its role as the ultimate, unseen anchor in the heart of yet-to-be-formed cosmic structures. Tomorrow night, we will journey deeper into the vast and ancient homes of these silent giants, contemplating their enigmatic presence at the very core of galaxies, beneath the tranquil glow of countless stars. At the very core of swirling galaxies lies a profound secret. Imagine an invisible anchor, holding billions upon billions of suns in a graceful celestial dance. Here, in this quiet, powerful center, the universe reveals its hidden order, a grand design guided by an unseen hand dot as you rest in the deep quiet of the night. Your mind may still hold the image of a massive star's spectacular end, scattering its precious elements across the cosmos. Tonight, we journey not to the birth of a single black hole, but to the grand, majestic homes where these silent giants reside, silently guiding the ballet of billions of stars. We turn our gaze towards the very heart of galaxies. Imagine, if you will, our own Milky Way, a vast, self-swirling island of stars, gas, and dust, gently spinning in the cosmic ocean. From far away, it appears as a shimmering spiral, a luminous disk adorned with countless points of light. This grand structure, This cosmic city of stars holds hundreds of billions of suns, each a story, each a world, all bound together in a delicate gravitational embrace. What, you might wonder, holds such an immense structure together? What guides its stately rotation, preventing its countless residents from simply drifting apart into the emptiness? For a long time, the center of our galaxy, and indeed the centers of most galaxies, remained a profound mystery. Covered by thick veils of dust and gas, our visible telescopes could not penetrate the obscuring cosmic clouds. It was like trying to see the heart of a dense forest from above, without the ability to peer through its leafy canopy. But through the use of other forms of light, radio waves, infrared light, and X-rays, which can pierce through these cosmic curtains, we began to uncover a most astonishing secret dot at the very heart of our Milky Way, and indeed at the core of nearly every large galaxy we have observed resides an incredibly massive, yet completely invisible entity. This is not just a single, stellar mass black hole born from the death of one star. This is a supermassive black hole, an object whose mass can range from millions to tens of billions of times the mass of our sun. These are the ultimate cosmic anchors, the silent gravitational monarchs of their galactic domains. Yet, despite all we have learned, black holes continue to challenge our understanding. What truly happens at the singularity, that point of infinite density at their very core? Does information truly vanish once it crosses the event horizon? Or is there a subtle cosmic re-encoding we do not yet comprehend? Are there smaller, primordial black holes, tiny remnants from the very dawn of the universe, waiting to be discovered? These are the questions that continue to spark curiosity in the minds of scientists and dreamers alike, pushing the boundaries of our knowledge and inviting new generations to explore the deepest corners of reality. The universe is vast, ancient, and endlessly surprising. Its deepest secrets are not always shouted. Often they are whispered in the quiet bending of light, in the subtle dance of distant stars, or in the almost imperceptible shivers of spacetime. The journey we have taken tonight is but a small step into this grand cosmic narrative, a gentle invitation to wonder about the profound interconnectedness of all things, from the smallest particle to the largest galaxy dot. As your thoughts begin to soften and your consciousness gently drifts, know that the universe holds boundless wonders yet to be unveiled. The black holes, these silent sentinels of space and time, remain a profound mystery, inviting you to rest now, knowing that the deepest secrets often reveal themselves in the quietest moments of contemplation, just as they do in the deep, peaceful stillness of your sleep, a final reflection, the cosmic embrace of sleep. And so, our gentle voyage through the cosmic dark, through the wonders and mysteries of black holes, concludes. As the whispers of the universe fade into the quiet hum of your own resting mind, remember that you are a part of this grand, unfolding story. The stardust that forms you, the very elements that make up your being, were forged in the hearts of ancient stars and scattered across the cosmos, just as we discussed. You are connected to these deep mysteries, to the silent dance of galaxies, to the profound, unseen forces that shape reality. Let the vastness you have explored tonight bring a sense of profound peace. Feel the quiet pull of gravity holding you gently, securely to your bed, just as it holds planets in their orbits and galaxies in their grand design. Allow the knowledge of the universe's endless wonders to settle in your heart, sparking a gentle curiosity that can nourish your spirit. May this journey into the cosmos leave you with a quiet sense of awe, a feeling of deep connection to something immense and beautiful. As your consciousness drifts into the soft embrace of sleep, know that the universe continues its grand, silent work, always unfolding, always inviting new dreams and new discoveries. Sweet dreams, cosmic traveler. Now, gently close your eyes if they are not already, Take one last deep, calming breath and release it slowly, letting go of any lingering thoughts of the day. May your sleep be deep and undisturbed, a quiet sanctuary where your mind can rest and rejuvenate. May you awaken refreshed, filled with renewed wonder, and ready for the gentle light of a new day. Sleep well, dear cosmic traveler. When colossal forms collide or dance in their final embrace, they send out subtle shivers across the vastness, like ripples spreading gently across a tranquil pond. These are the gravitational waves, the soft, distant melodies of a universe in motion, carrying whispers of events so grand they stretch the very boundaries of our understanding. As you drift deeper into peaceful slumber, your mind still contemplating the profound dips and warps that black holes create in the fabric of space-time, let us now consider the echoes that these cosmic giants can send across the universe. Tonight, we will explore the subtle shivers that ripple through the very essence of reality, carrying whispers of the most titanic events imaginable. These are gravitational waves, the universe's most profound silent melodies. Imagine once more our vast, tranquil cosmic pond, the seamless blanket of space-time. When a small pebble is dropped into a still pond, you see tiny, gentle ripples spread outward, carrying the energy of that disturbance across the water's surface. Now, instead of a pebble, imagine two immensely heavy stones, perhaps two colossal bowling balls, gracefully spinning faster and faster around each other, then eventually merging into one. If these stones are black holes, their final cataclysmic dance and union create a disturbance so monumental that it sends profound ripples not through water, but through the very fabric of space-time itself. These are gravitational waves. They are not like light waves, which are ripples in electromagnetic fields. Instead, gravitational waves are ripples in the geometry of space-time itself. They are transient distortions, stretches, and squeezes that propagate outward from their source. At the speed of light, carrying information about the most violent events in the universe. They are the silent tremors of the cosmos, the grand, unseen vibrations of reality. For a long time, gravitational waves were merely a prediction of Einstein's theory of general relativity, a beautiful mathematical consequence that seemed almost impossible to detect. The effects they produce are incredibly tiny, so subtle that they are nearly imperceptible. Think of it, when a gravitational wave passes through you, or through our entire planet, it momentarily stretches and then compresses all of space, including your very body, by an unimaginably small amount, less than the width of a single atom. To detect such a minute change seemed like a dream, yet humanity, with its boundless curiosity and ingenuity, found a way. Here on Earth, we have built magnificent detectors, instruments of exquisite precision designed to feel these cosmic shivers. The most famous of these are the LIGO, Laser Interferometer Gravitational Wave Observatory detectors. Imagine two long, perfectly straight tunnels, miles in length, arranged in an L shape. Lasers are fired down these tunnels, bouncing back and forth, their light beams precisely timed. If a gravitational wave passes through, it will momentarily stretch one arm of the L and compress the other, then reverse the effect. This minuscule change, perhaps smaller than 1/10,000th the diameter of a proton, would slightly alter the path length of the laser light, causing a detectable shift in the way the light waves combine. It is like listening for a whisper in a hurricane, but with instruments so perfectly tuned that they can pick up that almost imperceptible sound. In 2015, after decades of dedicated work, these detectors finally felt the first direct tremor from the universe. It was the whisper of two black holes, each many times the mass of our sun, spiraling into each other and merging far across the cosmos over 1 billion light years away. This detection was a monumental achievement, opening a brand new window onto the universe. Until then, we had only seen the universe through light, through radio waves, X-rays, visible light, and so on. But now we could feel it, sensing the vibrations of space-time itself. Since that first detection, we have felt many more such ripples. We have detected the mergers of other stellar mass black holes, and also the collisions between black holes and neutron stars, the ultra-dense remnants of massive stars that didn't quite collapse into black holes. Each detection tells us a new story, a unique melody from the cosmic orchestra. These gravitational waves carry pure, undisturbed information about the events that created them, unhindered by cosmic dust or gas, which can obscure light. They are the universe's ultimate messengers, bringing news directly from the heart of cosmic violence. These ripples also offer us a new way to explore the very nature of space-time near black holes. By studying the precise patterns of these waves, scientists can learn about the fundamental properties of these extreme objects, their masses, their spins, and how they behave in their final moments before merging. It is like listening to the distinct sound of a bell to understand its size and material. The sound of gravitational waves reveals the characteristics of the black holes that produce them. The study of gravitational waves is still in its infancy, a quiet dawn in our understanding of the universe, but it promises to reveal secrets we could never uncover with light alone. It might allow us to peer into the very first moments of the universe, or to understand how supermassive black holes at the centers of galaxies grew to such immense sizes. By detecting the fainter, longer wavelengths of gravitational waves that are yet to be fully explored, rest now, with the awareness that even in the deepest silence of space, there are profound vibrations, silent shivers that tell tales of colossal forms dancing their final majestic waltz. These are the gravitational waves, the universe's own heartbeat, pulsing softly through the cosmic pond. Tomorrow night, as our journey through the enigmatic voids begins to gently conclude, we will reflect upon the vastness of what we have learned and the even greater mysteries that still await our quiet contemplation, inviting you to embrace the unfolding wonder of the unknown. As our journey through the cosmic dark draws to a close, remember that the universe holds boundless wonders yet to be unveiled. The black holes, these silent sentinels of space and time, remain a profound mystery, inviting you to rest now, knowing that the deepest secrets often reveal themselves in the quietest moments of contemplation. As you rest deeply, feeling the gentle rhythm of your breath, our quiet journey through the enigmatic voids of the cosmos gently draws to its close. We have wandered through the whispers of nothingness, felt gravity's profound embrace, observed the very fabric of space-time, unfurl and dip, ventured beyond the veil of light, and listened to the distant echoes and silent ripples carried across the cosmic pond. Tonight, let us simply reflect on the vastness of what we have explored and the even greater wonders that still await our understanding, inviting you to drift into dreams filled with cosmic awe. Remember, the story of black holes is not a tale fully told. It is an ongoing narrative, a profound mystery that continues to unfold with every passing year, with every new whisper detected from the universe. These silent sentinels born from the fiery demise of colossal stars and anchoring the very hearts of galaxies represent the most extreme expressions of gravity, bending and warping the very essence of reality itself. They are cosmic paradoxes, dark yet revealed by brilliant light, empty yet filled with unimaginable density, silent yet sending out profound tremors across billions of light years. We have learned that a black hole is not a hole in the ordinary sense, but rather a region where space-time has become so deeply curved that nothing can escape. The event horizon, that shimmering invisible boundary, marks the ultimate point of no return, a cosmic threshold beyond which our familiar laws of physics seem to converge and transform. Within that veil, time slows to an infinite crawl from an outside perspective, and all paths lead to a mysterious, infinitely dense singularity. This is where the universe holds its most guarded secrets, tantalizing us with the knowledge that there is more to discover than we can yet grasp. Think of the sheer elegance of how we discover them. We cannot see them directly, yet their presence is undeniable, evidenced by the fiery dance of matter spiraling into their embrace, emitting brilliant X-rays and gamma rays that paint their portraits across the heavens. We see their influence in the swift, dizzying orbits of stars around an invisible center, a cosmic ballet choreographed by an unseen gravitational hand. And most recently, we have begun to feel them, detecting the infinitesimally small ripples in spacetime gravitational waves that echo across the cosmos from their most violent collisions. Each of these observations is like listening to a different part of a grand silent symphony, slowly revealing the nature of the unseen conductor, the existence of supermassive black holes at the heart of nearly every large galaxy, like the one anchoring our own Milky Way, reminds us that these objects are not rare anomalies, but fundamental components of the universe's grand architecture. They are not merely destructive forces, but active participants in the evolution of galaxies, their immense gravitational presence shaping the majestic spirals and ellipses we see scattered across the night sky. They are the silent guardians, with powerful anchors around which cosmic structures gracefully unfold. Think of it as the ultimate cosmic pivot point. Imagine a colossal, invisible gyroscope, infinitely heavy, around which an entire city of stars gracefully spins. The sheer gravitational force exerted by these supermassive black holes is what orchestrates the grand swirling dance of a galaxy. They don't suck in stars from across the entire galaxy in an active, destructive manner, for stars are often very far away. Instead, their immense presence acts like a profound gravitational well at the very center of the galactic disk, shaping its rotation, giving it its characteristic spiral or elliptical form. Consider the stars closest to this galactic heart. They are not slowly spiraling into the black hole, at least not typically. Instead, they are orbiting in at incredible speeds, their paths determined by its overwhelming gravity. We can observe these stars, watch their swift, tight pirouettes around an invisible point, and from their rapid movements, we can precisely calculate the enormous mass of the unseen object anchoring them. It's like watching a group of dancers swirling around an empty spot on the stage, their movements revealing the hidden presence of the choreographer. Our own Milky Way's supermassive black hole is known by the poetic name Sagittarius, pronounced a star. It resides about 26,000 light years away from us, far in the galactic core. Its mass is estimated to be about 4 million times that of our Sun. While this sounds incredibly vast, its event horizon is surprisingly compact, roughly 17 times the diameter of our Sun, a tiny speck compared to the sprawling expanse of the galaxy. The environment around a supermassive black hole is far from empty or calm. While the black hole itself is dark, the region around it can be a place of intense activity. Gas and dust, sometimes entire stars, can occasionally drift too close to the supermassive anchor. As they do, they are shredded by the immense tidal forces, stretched and pulled apart, and then form those blazing accretion disks we spoke of last night. These disks around supermassive black holes can be so hot and bright that they outshine all the billions of stars in their host galaxy combined, blasting out powerful X-rays and gamma rays. Such actively feeding supermassive black holes are known as quasars, the most luminous objects in the early universe, shining like cosmic lighthouses across billions of light years. These galactic nuclei, these central anchors, are thought to have played a crucial role in the formation and evolution of galaxies themselves. It is believed that supermassive black holes and their host galaxies grew up together, influencing each other's development in a complex symbiotic relationship that we are only just beginning to understand. The black hole might have helped regulate star formation in its galaxy, while the galaxy provided the fuel for the black hole to grow. They are deeply intertwined, like the root and tree of a cosmic forest. So, as you drift further into your dreams, take comfort in the thought of these silent, powerful anchors at the hearts of galaxies. They are not merely destructive voids, but fundamental components of cosmic architecture, holding together the grand design of the universe. Their immense gravitational presence is a testament to the quiet order beneath the chaos of countless stars, a hidden hand guiding the most majestic structures in the cosmos. Tomorrow night, we will delve even deeper into the very substance of this cosmic ballet, exploring how these colossal anchors sculpt not just the paths of stars, but the very essence of reality around them, creating profound dips and warps in spacetime itself. Picture the universe as a soft, yielding blanket, and now imagine the deepest indentations, valleys where time itself seems to slow and distance becomes a fleeting concept. We journey into these profound depths, understanding how the most massive objects sculpt the very fabric of reality, creating contours where dreams and wonder reside. As you rest in the quiet ebb and flow of your breath, let your mind gently journey back to the heart of galaxies, where immense, unseen anchors silently guide billions of stars. Tonight, we will delve deeper into the very nature of these cosmic architects, exploring how their incredible presence doesn't just pull on things, but sculpts the very stage of existence itself, the fabric of spacetime. Recall our earlier image of space-time as a vast, infinitely pliable blanket stretching endlessly through the cosmos. We've seen how a star creates a deep dimple in this blanket, guiding the paths of planets and light. Now, let your imagination stretch even further. Imagine the supermassive black holes at the heart of galaxies, those colossal anchors we spoke of last night. When such an incomprehensibly massive object rests upon this cosmic blanket, it doesn't just create a dimple or a deep well. It creates a profound, almost infinite indentation, a valley so deep and steep that it alters the very nature of the fabric around it. Think of it as a deep, swirling vortex in the blanket itself. The threads are not just stretched, but profoundly warped, pulled inward and downward towards a central point. This isn't just about space being curved, it's about space-time being curved. This means that not only are the distances distorted around such a massive object, but time itself experiences a dramatic change. In these profound dips, these cosmic valleys around black holes, time slows down in a truly remarkable way. We touched upon this briefly before, but let us feel it more deeply now. Imagine a gentle river flowing steadily. Far from the black hole, time is like that river, moving at its constant, familiar pace. But as you approach the deep dip, the profound curve in spacetime caused by a black hole, it is as if the river of time itself becomes incredibly sluggish, thickening and stretching. A single second experience close to a black hole would last much, much longer for someone far away. This is not just a trick of perception. It is a fundamental property of reality. If you could somehow hover just outside the event horizon of a black hole and someone far away observed you, they would see your every movement slow to an agonizing crawl. Your words would stretch out into deep, drawn-out syllables, your gestures becoming almost frozen in time. From their distant perspective, you would appear to move in a dreamlike, eternal slow motion. Yet for you, in your immediate experience, time would feel perfectly normal. Your heart would beat at its usual rhythm. Your thoughts would flow at their accustomed speed. The profound slowing of time would only be apparent when comparing your experience to that of someone in a weaker gravitational field. This phenomenon, known as gravitational time dilation, is a subtle whisper of how deeply connected space and time truly are. They are not separate entities, but two interwoven strands of the same cosmic fabric. And when one is profoundly warped by immense mass, the other must respond in kind. This is why our GPS satellites, orbiting high above Earth, must account for tiny gravitational time dilation effects to ensure their precision. Without these corrections, your navigation system would quickly become inaccurate. The universe's subtle truths are often hidden in plain sight, influencing our daily lives in unexpected ways. Now, let us consider the concept of distance within these deepest dips. Ordinarily, a straight line is the shortest distance between 2 points. But in a profoundly curved space-time, what appears to be a straight line to us from afar might actually be a curving path through a warped region. It's like trying to navigate across the surface of a crumpled piece of paper. The distance between 2 points can be very different depending on how the paper is folded dot around a black hole. The deep dip means that distances are profoundly altered. Imagine being very close to the event horizon. To reach a point just a little further away, you might have to travel through a space that is so curved, so folded, that the perceived straight path is incredibly long. It is as if space itself is stretching and contracting around you, making simple navigation a profound challenge. Light itself, as we discussed, follows these curves, which is why it cannot escape once it crosses the event horizon. It is always directed inward by the profound curvature of the space-time fabric. These deep dips in space-time are not merely abstract concepts from equations. They are real, tangible alterations to the very reality around black holes. They are the ultimate expression of gravity's power, not just to pull, but to reshape the fundamental dimensions of our universe. They create cosmic landscapes where the familiar rules of geometry and chronology bend and twist, inviting us to contemplate the profound flexibility of existence itself. The presence of these supermassive black holes at galactic centers, creating such immense spacetime distortions, highlights their role not just as gravitational anchors, but as cosmic sculptors. They are silently, continuously shaping the contours of the universe around them, influencing how light travels, how stars orbit, and even how time itself flows. It is a subtle yet powerful influence, revealing a hidden elegance in the universes. Designed out as you drift now, let your thoughts quietly settle on this profound idea that mass doesn't just attract, but that it molds and reshapes the very essence of space and time. These are the universe's deepest valleys, where reality takes on new, wondrous forms. And when such titanic objects dance, when they merge or violently interact, they do more than just create deep, still dips. They send out tremors, profound ripples through this very fabric, carrying whispers of their immense power across the vast silence of the cosmos.